Lesson 3.6, compound interest. Now, if you've worked with compound interest before, you're probably familiar with this formula right here. Some amount in the future, some future value, is equal to the principal times 1 plus your interest rate, your interest rate divided by the number of times it's compounded per year. All of that raised to the number of compounding periods times annually, times the number of years. Okay, so we'll run through a quick example. We put $1 in. We're going to put it in at 5% interest. Notice that's not 5 with the little percent sign. It's 0.05 or 5 per century or 5 per hundred. Okay, so 0.05 is the interest rate. We're going to compound it 4 times annually. N is 4. And we're going to let it sit for 10 years. Whoa, that's probably there. Okay. Let it sit for 10 years. All right. So 4 times 10 is 40. We're going to compound this 40 times. Here's our 0.05 divided by 4 plus 1 is 1.0125. We're going to raise that to the 40th power. And that's going to be equal to $1.643, okay, or just $1.64, okay. Now, what happens when we let n become very, very large? When we let n become very, very large, this factor here goes to a value called e, and that's the natural number. And I'm sure you can look up what that actual value is. All right, and so we're going to be using a different formula. Here's our formula. The principal, or the future value, same thing as the future value, is equal to the principal, or the initial value, times e raised to the interest rate times time. Okay. And again, we have that caution about the interest rate. Be sure to change your percentage to a decimal. A growth rate of 2.3 in decimal is 0.023. The base e raised to the power 2.3 returns a very different value than if you raise that to the power 0.023. And I invite you to experiment with that and confirm that for yourself. Okay, so here's our equation. Future value, in this case, P is probably population, initial population, which is our current value. And then we have our base that we're using, which is the natural E, the natural number, okay, times the interest rate times the time. The interest rate is the annual growth rate. Okay, let's figure out what our doubling time is first. Okay, that's the time it takes for the initial value, the initial population, to double, the initial principal to double, whatever it is that we're using for P naught, or the P initial. What time does it take for it to double? Okay, we're not given either P or P naught, but we do know the value of the future value over the current value, or the initial value, because it's the doubling time. P over P naught is equal to 2. So we're going to divide through that equation. We're going to divide through by the initial value. We have P over P naught, which we know is equal to 2. Okay, so we have 2 equals E raised to the KT power, the interest rate times time. Next, we're going to extract the exponent from inside the natural. We're going to take the natural log of both sides. That's the first thing. And then we're going to extract the exponent from the inside of the natural log. Okay, so if we take the natural log of a quantity that's a base to some exponent, that's also equal to whatever that exponent is multiplied by the natural log of that base. So if this is our base, we can take the natural log of it. We extract KT as the exponent, and that's how we get access to it. Okay, so we take the natural log of both sides. Natural log of 2 is equal to the natural log of e raised to the KT power. natural log of 2 equals kt. And see there, we've taken that exponent out, equals the natural log of e. Now here we're going to recognize that the natural log and exponentiating to e are inverse functions. I'm going to recognize that that's just 1. Okay. The natural log of 2 equals kt, because remember this is now equal to 1, so we can just drop it. Okay. Natural log of 2 equals kt. We solve for t. And that's our time. Let's remember that doubling time, that bit of information about doubling time is contained in this number 2. So we have the natural log of 2 divided by our interest rate is equal to the time it takes for an initial quantity to double. For the interest rate, given the doubling time, we take the second to last expression, this portion here, and we're going to solve for k instead of t. So we have a very similar expression that we can work with. The initial value given the final value, multiply both sides of the equation by e to the minus kt. Okay, so we start here with our initial equation. We're going to multiply by e to the minus kt. Notice before we're working with e to the kt. Okay, so e to the kt times e to the minus kt. Okay, we'll just go ahead and remove that red highlighting there. And then we're going to use the identity a to the n times a to the minus n. As long as we have the same bases, we have a to the n minus n, which is just a to the 0. Anything to the 0 power is 1. So this whole quantity here is equal to 1, and it goes away. So the initial value, given the value at some later time, times e to the minus kt, e raised to the power minus kt, is the expression that we're going to use to find that initial value. Okay, I hope that was helpful. If you have any questions, please ask in the discussion board, and I will do my best to help you out, okay?